Kabir is a principal scientist at Delhivery, where he joined after being a lecturer at the University of Greenwich. He also got a PhD from the same university, University of Greenwich. His research interests revolve around machine scheduling with logistic decision making.
Hi. Okay, so those of you who are not aware of Delhivery, the company, I'll give a quick intro. Delhivery is one of India's largest third-party e-commerce logistics companies. We are the company that delivers about 20% of India's shipments when people order online on the likes of Amazon, Flipkart, Myntra, etc. I lead the data sciences team at Delhivery. Does this work to change?
No, it's actually not. So sorry about that.
So just to give you a quick sense of the typical life cycle of a shipment when we pick it up from our clients. So we pick it up from the clients, take it to our processing centers, sort it based on what the end destination is, transport it to the destination city. From the destination city, we take it to the last mile delivery center, from where it goes to the end customer's house. As you can imagine, it's a huge graph problem, really. And there are lots and lots of optimization opportunities around, which makes it very interesting for someone of my academic background. However, you cannot ignore machine learning and AI here, because any optimization problems does need its constraints and parameters, which is what we need to learn from the ground. In this case, the most important parameter is where to deliver the shipment to the end customer. I really need to know where my customer is. What I normally have is just a noisy piece of address, which is just some noisy string, which doesn't necessarily tell me exactly where the address is. To optimize anything, I need the exact lat long. If I have that, I can really do all sorts of optimization and save money for the company. Typically, address disambiguation is a huge problem in India because of addresses like these. So this is a sample of addresses from two shops in Chandni Chowk, which is in Old Delhi, a very congested neighborhood. These are two shops right next to each other. Have a look at how different the address structure is. So one is 1880/13-M-16. The one next to it is 1858/W-2. This is not where the problem finishes, right? In different parts of the country have addresses written in different shapes and forms. Some addresses are written in terms of building names, some in street names, some revolve around points or person of interests in smaller towns or workflows. A common thing that we have is on the weekend try here, on the weekday try here, which makes it extremely hard for us. A threat even. I mean, this is scary. The person writes a proper house number, village number, post office, police station, district, all very sincerely, but follows it up with a very scary threat. I want all products which I had already been ordered should be original, otherwise I take strict action against you because I'm CAID officer from Punjab. Last time I ordered, the mirror and the second hand was broken, etc. So besides scaring us, this makes our life extremely hard because I need to then disambiguate this address somehow and figure out where to deliver to this CID officer. Even when people write good addresses, there's a problem. PIN codes, normally in all other parts of the world, Western parts of the world especially, PIN codes are sufficient. In the UK, for example, any PIN code would take you within 100 to 200 meters. In India, typically it'll take you within 90 square kilometers. That's the median size of a PIN code in India is 90 square kilometers. And about 35% of them, or 30% of them are written incorrectly. They're written incorrectly not because of any malicious intent, just because people don't know what the PIN code is. Also, all sorts of funny localities in a city. Calcutta, I'm not from Calcutta, but I've been told it's got 3 Rathatalas in Calcutta, and combine that with the incorrect PIN code, it becomes a nightmare. Similar spelling localities, Amritnagar versus Amrutnagar. It makes it hard for the machine to understand. This one is a nightmare again. Andheri West versus Andheri West or East. I don't know. It's one edit distance away from both. So these things are hard. Besides could mean anything, next to, behind, next to my grandmother's house. I don't know. It can be really anything. So typically on a good day, our delivery boys have a tough time, and on a bad day, don't even ask. So what is a solution? One obvious solution which has been doing rounds in the news the past couple of months or 3 months is standardized addresses, right? Google has been going into press rather aggressively over the last 2 days on plus codes. You see it everywhere. Since I'm working on this problem, I'm getting these pings from all around the country, really. So plus codes, robocodes is an initiative by a team in MIT Emerging Worlds Lab. You've got eLock, MapMyIndia, What 3 Words, it's a UK-based company, Zipper, and then more. These are the more famous ones. Or the other way to do it is learn to use whatever you've got, which is the more immediate solution. Although these 5 are extremely promising, but I see it's several years away till there's a decent amount of adoption. No offense to the guys who made plus codes, but I would find it extremely hard to remember 8-character alphanumeric string, which I have never used before. I'm sure by the time I start using it, it'll be several years. So the current need is to disambiguate whatever I have, identify the city, identify the locality, identify the pin code, sublocality, whatever there is in the address string, and then try and determine a geocode from what I have disambiguated. To do this, the information I have is 2 types of data. One is unlabeled data, which is all the shipments I've delivered to in the past. I have the address for those in whatever shape or size or format. We have delivered about 200 million shipments in the past 5 years. So I have raw address strings for 200 million shipments. Then I have location data. Every time I go and attempt a delivery, my delivery boy goes and captures a lat long when the delivery is successfully completed. Unfortunately, I don't have clean lat longs for each of the 200 million addresses. I should estimate we have around 10% of those, largely because for the first 3-4 years of the business, we did not capture those things. And in the next couple of years, when we've started making it mandatory, the delivery boys have been starting to game the system a lot. So we identify which ones are correct lat longs, which ones are incorrect, and so on. That's another machine learning problem altogether. But yes, we've managed to do that, which leaves us with about 20% of responses which are typically usable. Okay, so we have broken the problem into solution into 2 parts. One is, since I have huge amount of unlabeled data, I need to make use of it somehow. Obviously, one way is whatever 20 million labeled data points I have, I run it through a discriminative algorithm, and given any address, I get some lat long. We decided not to do that because, one, we did not get accurate enough results because there are parts of the country where I'm not very good with my mobile penetration. The other is I would like more visibility into how my prediction is being made. Besides, a generative algorithm which we use gives me access to a lot of byproducts which are used in downstream applications, which I'll talk about in a bit. So what we do is we take our 200 million. Actually, we don't take 200 million. We don't really need to. We take a small sample of those addresses and build a graph out of it. So we take one address at a time, tokenize it, take all the components of the address, and make relationships on a graph. So we typically train this on about 20 million a data set. So my graph eventually has relationship between each node in the graph represents a locality, sublocality, a pin code, maybe a name of the house. It could be the name of this building. The edges obviously represent how those nodes are connected. So you will have, I don't know the geography of Bangalore too well, so I'll use examples from Delhi. So you have a Vasant Kunj, and within Vasant Kunj you have pocket A, pocket B, pocket C, pocket D, and so on. So you have that hierarchical structure, which I have access to. All that is really deduced from how people are writing addresses. Sure? 1 minute, okay. I'm also able to decipher aliases, so spelling errors, alternative spellings, and so on. Gurgaon, Gurugram, Bangalore, Bangalore, and so on. I do this using multiple signals from the address data itself. I won't go into that detail now. The second part is the use of label data. So once I know what my nodes are in the graph, the second part is to figure out where they are. So I know that Sector 44 is a place in Gurgaon, Raheja Atlantis is a building in Gurgaon, and so on. Now I need to figure out where they are. I use my locality data from the mobile applications and associated with that node and build some sort of a polygon from that data. Now the polygon, you may notice, it's not really a convex hull or a concave hull. It's a mixture of, I use OSM road points as well. Using OSM road geometries and the points I have, we build some sort of a polygon. So that's the second part. Now every node in the graph has some polygon associated with it. The leaf nodes will have a few number of points, could be the rooftop lat longs, and so on. The last step is at the time of prediction, I run some sort of a fuzzy match. Now the fuzzy match is, we were not able to use any of the out-of-the-box fuzzy matching engines available because Indian languages are somewhat different. For example, Fagbada, I mean, these sound similar in Indian languages, but not really in English. So we had, at the time of prediction, we have some sort of a fuzzy search as well. Now this is a prediction, and that's my last two slides. That's my home address, B111. I'm misspelling it intentionally, Raheja Atlantis. It's Raheja Atlantis with a ending with an S. Sector 31 Gurgaon. So I'm not giving it the information Sector 31. This is the UI that we have internally. And so the tool searches through my graph, finds, does a fuzzy match on Raheja Atlantis with the existing nodes, finds Raheja Atlantis, figures out that the parent is Sector 31, figures out that the parent of Sector 31 is Gurgaon, the parent is Haryana, the parent is India, and so on. That's the polygon it made for Raheja Atlantis, which is fairly accurate. I don't agree with this point there, but besides that, it's fine. The polygon for Sector 31 is largely perfect. Now, interestingly, 2 months back when I was building this deck, Google Maps could not get this right. However, when I tried this morning, they managed to do this. So I tried another example. I tried my parents' address, which is B15 Gulmo Park, near Green Park Metro Station. This time we won. So anyways, it's able to figure out Gulmo Park. It's able to identify that near Green Park Metro Station is gibberish. I don't need to use that. Figures out where Gulmo Park is, gives a nice clean polygon, and does the job. So currently we are able to determine about 90% addresses. We are able to disambiguate 90% of the addresses to the sublocality or locality level. If the output geocode is roughly around 200 meters, this is becoming better and better every day as and when I do better at my sublocality level disambiguation, which is hard, which is a very hard problem because sublocalities are funny. They appear in your rooftop address, A161. Now, pocket A is the sublocality. People write 172/A. Now, /A, the latter part becomes a sublocality, which is a hard problem. That's what we're working on now, and hopefully we'll find a way to solve it. Once that happens, I'll be able to promise better resolution as well, down to the sublocality, hopefully in the rooftop. I'm done. For further reading, you can have a look at the blogs that have been published over the past couple of months. And you can find my details online somewhere if you would wish to contact later. Thank you.